Hello everyone, and welcome to a new session in this MicroStation Virtual User Conference. This session will be focused in the usage of MicroStation in water industry projects. My name is Eduardo Mendonça, and together with Eduardo Cortes, whom I will call Edu, we will be presenting the MicroStation for Water Industry session. We are covering three main topics. What are why MicroStation for water industry, global case studies in innovative design and engineering with examples of MicroStation key capabilities to empower water projects after every project case. Now I hand over to Edu for the next section.
Thank you, Eduardo, and thank you for the intro. Yeah, I will start speaking about why MicroStation, right? And we usually start with a sentence that say, MicroStation is the software professionals rely on to design, model, and manage infrastructure, emphasizing the model and infrastructure work, right? So the main purpose of MicroStation is enable user to deliver designs, but also we are delivering creative visualization. One of the things we are doing is consolidating critical project elements in a single environment for effective and secure per deliverables. You can see that we are defining in bold the keywords for us, right? MicroStation is also built or designed to work with any project site, from the smallest to the biggest one, for infrastructure project, because it's the software, the CAD software for infrastructure, and also is defined to support projects that can be there for days or for years, right? So it's also supporting projects in a long life cycle. And one of the most important things is that MicroStation is not only MicroStation. MicroStation is the foundation that supports the entire Bentley modeling ecosystem, right? And having this in mind, we want to review what we call the three key capabilities provided by MicroStation, summarized in three sections. One is model anything, anywhere. MicroStation is providing the capability to model anything you can imagine, always geolocated or related to the geospatial context, so you don't need to design disconnected from the system reality. The second key capability is the ability to read and consolidate anything. MicroStation is reading a lot of different file format in native format, more than 7 times any other application you can find. But also we are consolidating the data to produce the final project deliverable, right? And finally, the last capability we want to reinforce here is about report everything to inform everyone. With this aggregated model we created with MicroStation, we can create reports from different data, not only from the data we create with MicroStation. So a report coming from a building site, from a piping site, from a road site, and also we are publishing, we are creating reports, creating outputs, are feeding the digital twin with MicroStation. So this is a summary of the three key capabilities provided by MicroStation, and we will check how we are applying these capabilities to several examples of the water industry. Now I hand over again to Eduardo for the next section, where we will start speaking about real user cases and examples of how we are using MicroStation, or how the user uses MicroStation on these specific cases.
Okay, thank you, Edu. Well, the first use case is the sewage master plan of Jagdalpur in India. It's a project made by Sensis Tech. And for this project, the team modeled the area using MicroStation, integrating GIS and survey data into a visual modeling platform. Well, they used another applications like open flows, open sewer gems. So the applications streamlined workflows, facilitated clash detection, resolution, establishing a digital context, resulted in a cost-efficient wastewater treatment plant, and provided the basis for operations, maintenance, and asset management. For this use case, I will present this key capability called total freedom for modeling. Well, in MicroStation modeling workflow, you'll find tools such as solid primitives, solid operations such as extrude, revolve, loft, and sweep, as well as tools for creating and editing surfaces and meshes, allowing you to model anything you need. So now I hand over again to Edu for the next session.
Thanks, Eduardo. Yeah, I will explain something about this project from Hatch in Canada, that this is a treatment plant. This is a project where they used MicroStation together with other venting products like Open Roads and ProjectWise. The most important thing is this is a treatment plant that is one of the Canada's largest and oldest water treatment plant. It was built in the past century in 1910 and it started to be operational in 1917. So it was covering the Toronto area, right, and with a big hydraulic capability. But the project was asking Hatch to do a project of refurbishment, right, for more than $350 million, but they also really had to minimize costs as maximum while considering the environmental and underwater soil feature, right. So Hatch using Open Road to predict the geological boundary condition, but they also used MicroStation to model the elements of the shaft and the tunnel and creating the elements and the equipment needed to accommodate all the data inside the treatment plant, and also solving a connection problem, right? And also they were collaborating with different several time zones using ProjectWise to keep the project on time and under budget, right? So as an example of the capabilities they were using here, we selected an example of how MicroStation is working with parametric modeling. This is an example of a water plant equipment that this is how we can create component catalog, right? The idea to provide component catalog are parametric cell is geometry that react to variables. So both geometry and properties are always linked and connected. The catalog can be created with parameters and with variation. And the variation is based in one parametric model with a set of predefined variables that you can define, modify, and select the different variation of your equipment. So this is helpful for the manufacturers to create closer catalogs and for the user. And yeah, now I hand over to Eduardo for the next section.
Thank you again, Edu. Well, now we will talk about two use cases to talk about designing geospatial context, including reality and GIS data. This first one is the Indira Sagar project made by Larsen Itobro in India. So this project, they initiate a project to irrigate a 200,000 hectares of farmland by accessing water from the Indira Sagar reservoir. So they recognized the limitations of traditional methods and variables photogrammetry software, realized that they required full life cycle digitization to meet modeling and mapping demands. So they conducted aerial LiDAR surveys using context capture and MicroStation to process the point clouds and integrate GIS data from their in-house web portal. With that, they generated accurate 3D reality meshes for this project using Bentley applications. In the next project, regarding the same topic, is the Société Wallon des Eaux in Belgium. They used 3D reality mesh for water crack detection. So in this case, previous surveys revealed damage. So they took ground photos to define the renovation works, but missed the most significant damage. To refine their methods and obtain a more insightful assessment of the water tower's condition, they needed to apply photogrammetry, machine learning, and 3D modeling technology. In this case, they selected context capture insights to process over 3,000 images and generate a digital twin of the tower to visualize the entire structure and assess the damage. So the digital twin could be completed in one day, enabling quick assessment and remediation plan to ensure a reliable water supply. For this capability, I would like to present this another interesting feature that MicroStation provide, that is the option to directly use context capture data and accurately represents SB conditions. In this case, using MicroStation, we animated a moving crane to determine whether there would be clashes before bringing the crane into the real position. This can be very critical to avoid issues during works that can be prevented with a good previous analysis. Okay, now again with you, Edu, please, for the next use case and capability.
Thank you, Eduardo. Thanks a lot. Yeah, the next case is very interesting. This is about an integrated water supply project in Sri Lanka, and they were using the combination of MicroStation and open flows. That in this case, the region, Sri Lanka region, is depending on groundwater sources, so they need to take the high salinity water from the ground and permanently process to have drinking water, right? So there was a lot of financial constraint, and the client requested separate water distribution designs to accommodate an 800 kilometers pipe covering all roads and a 355-kilometer pipe length spanning selected roads. So in this case, the user was using MicroStation and open flows. OpenFlow was used to create the analysis of the water network, but MicroStation was used to create a geo-coordinated model of the water network, right? So considering also the real-time field condition. So they were facilitating the integration with third-party GIS data and planning features, and also show a dynamic modeling to evaluate numerous network scenarios, right, for better decision making. So we have an example of something similar, that is how we can attach data in MicroStation from another application, but also geolocate the elements. We define a geocoordinate system. So at the end, what we want to do is view the position of the design on top of the Earth. So then when we are establishing geographic location condition to the report, or analyzing the network together with the terrain, we can do it because we are combining both data, MicroStation and open flows and MicroStation in the same coordinate system. So we can also combine with road, area, or hybrid map behind the water network. Now I'm going again to Eduardo. Yeah.
Thanks a lot, Edu. Well, this is the Singapore General Hospital. This project was the intelligent design of automated waste management for this hospital, made by Stream Environment. They create a total solution provider of automated waste collection systems. Stream Environment was retained to perform engineering, conceptual, and detailed designing for this Singapore General Hospital. Given the project's strict schedules and tight deadlines, Stream Environment needed a comprehensive alternative to traditional CAD software. So the electrical team implemented MicroStation and Promise-E to model and visualize the entire system, as well as automate production of electrical drawings. And this project, Bentley Applications, helped the team create standard component libraries and automate previous manual process involving design accuracy and ensuring compliance with international standards. For this key capability, I'd like to play this video about data integration and interoperability. Okay, MicroStation can open, import, and reference dozens of file formats, whether Bentley, third-party, or open formats. Here's an example of a water treatment facility designed with different products. Concrete for clarifiers and foundations were completed with Bentley Pro Concrete, and steel was done with Pro Steel. Some equipment was done with Open Plant, as well as the underground and above ground piping, other imported from equipment vendor models. All models are federated or consolidated into MicroStation. With that, it becomes a powerful data integrator, allowing several operations of drawings, modeling, reporting, drawing extraction, project coordination, among other activities. Now, again to you, Edu, please, for the next.
Thank you, Eduardo. Yeah, the next example we want to share with you is in Houston, in the States, is the Northeast Water Purification Plant expansion. In this project, the Houston Water Works team was trying to help to reduce the dependency on groundwater and increase the amount of fresh drinking water. So they need to initiate an expansion of the current purification plant. So obviously, there was also some BIM requirement, right, to include the handover of the federated model and the production of more than 5,500 construction drawings. So the team established a connected data environment using several Ventil products, Open Plan, Open Buildings, and MicroStation. And the connected data environment helped designing in context and conduct declare detection. As similar to the example you saw before, there was an aggregated model with everything, with all the data, trying to do this analysis. In this case was declare detection, right? So in this example, you can see more or less something like they were done in the user case. That is, having all the model federated into MicroStation to do common multidisciplinary analysis. In this case, we are using declare detection to do an analysis between the plan elements versus the architectural elements, in this case all the structural elements, and identify what are the issues and also identify information from the element which having the issue. So if the issue is a pipe versus a wall, we can identify the information about both elements and also know where are located, so we can ask other people in the team to solve the issue, right? So that you can apply separation rules, you can interactively review the classes, and also can be grouped, marked, and exported for other colleagues' review, even in a format like Excel spreadsheet, right? So yeah, now I hand over again to Eduardo for the next example.
Okay, Edu, thank you. Well, this is the Al-Haman New Delta agricultural drainage water treatment plant made by Resco in Egypt. So GESCO was contracted to build an agricultural drainage water treatment plant, one of the world's largest of its type, south of Al-Haman. So they needed flexible digital applications that could accommodate the wide scope of the project. So PGESCO used ProjectWise to establish an open, connected data environment, helping team members in various disciplines to manage, share, and distribute project information, making all documents and engineering drawings readily accessible as needed. Additionally, they used MicroStation for designing and drafting. And for this key capability, I'd like to talk about the hypermodeling technology, MicroStation. This will help you to navigate between 3D models and 2D drawings dynamically in the same environment. In this example, we are creating the documentation for a model by using MicroStation section callout tool. This tool allows you to very quickly and easily create a section or plan drawing directly from our model. Just defining the section line. The creating drawing tool allows us to create all the plans, sections, and elevations needed directly from the 3D model. With all the drawings created, just navigate to an empty sheet, for example, to drag and drop from the MicroStation Explorer. All the drawings needed to create automatically, intuitively the final composition for your project. Then once you have your sheet ready, just using the bubble, you can quickly jump from the 2D drawing to the 3D model and check sections and model in the same view, for example. That's this capability. Now, again to you, Edu, please, with the next section.
Thank you again, Eduardo. Yeah, the next example is based in France. It's a water treatment plant done by Saur, right? So this is another big project. This is more than 5 million project that was initiated to replace an 60-year-old water treatment plant. This treatment plant was all no longer meeting the applicable water regulation or not accommodated for the growing population. So they need a new facility that it was equivalent to a water treatment plant with a 900 cubic meter per hour capacity. So in this case, the user, Saur, to optimize design and win the contract, they choose to implement 3D modeling and visualization technology. So they use MicroStation to model and analyze the facility and to share the information, to present it to the client, right? And working in MicroStation was for them very easy to work in a multidisciplinary design integration. They saved 20% in time to delivering the project, right? But also the most important thing for them was the quality of the graphic rendering and visualization tools of MicroStation enabled them to present an accurate and realistic representation of the design to win the contract. As an example of this, you can see here an aggregated model, and the aggregated model of the water treatment plant is transferred to LumenRT. LumenRT can take this model from CAD, from BIM, from GIS, and transform into a real 3D immersive scene. We call it live cues, and these live cues are completely self-contained of 3D environments and allow you to place more elements or enrich the environment. The thing is, or the most important thing here is, you don't need to be a rendering expert, a visualization expert to produce stunning images and animation. It's very easy to do it. And also the new view rendering engine is simplifying the process, so you're reducing the settings, so you can automatically, you can do material assignment, PBR, physical rendering images and path tracing. And yeah, there's some examples of what you can create. As we spoke, you can create static images or you can create animation with both, and they are appearing quite with very good quality. Yeah, now I hand over again to Eduardo for the next section.
Thank you again, Edu. This is the last example. This is the Marpol waste treatment plant designed by Coba. It was in Freeport, the Grand Bahama Island. This is the state-of-art Marpol waste treatment plant facility. It will receive and treat oily residues to produce a high-quality fuel that can be sent to local markets or exported for sale. Coba was responsible for preliminary and detailed designing, as well as for performing a hazard and operability study. The multidisciplinary design team faced a limited footprint with a complex piping layout. So Open Plant and AutoPipe helped model and analyze design alternatives for the piping and equipment. Open Buildings Designer was used to identify and resolve conflicts between the piping layout and structural elements. And the interoperability of MicroStation facilitated development of a digital twin. And then using a connected data environment based on ProjectWise, streamlined digital workflows. And the capability is feed data to the digital twin. Using digital twin, team members can synchronize their design changes from a design file to an iModel on the iModel hub using the iTwin synchronizer. This iModel is then available for review to all team members. The flow of information between the various phases of an asset's life cycle, like design, construction, operation, and maintenance, will be more efficient and seamless by such collaboration. For example, in a complex infrastructure project with data from multiple disciplines and products like MicroStation, Open Road Designer, and also Revit, it will now be possible to have design data from all these applications within a single iModel. So changes to the project can be continuously pushed to this iModel from all these applications to keep it up to date for design reviews using iTwin Synchronizer. Then this iModel will just consolidate all required design information, which can be accessed by the team members from any location. And to share files associated with a project, such as references, pod files, 3MX, rasters, etc., with a team member, you only need to push your changes in the design file to an iModel, and then share a link to the iModel with them. And then the team members you share this link with will be able to view, examine, and analyze the data stored in the iModel from any location.